observers out on trapping boats for the first time. The Canadians have done a lot of interesting work on growth and the timing of sex transition. Anne's done some really interesting work on temperature and the timing of egg hatch. So there's a lot of stuff that's happened in shrimp science over the past decade or so that we're not talking about today. Today we're just talking really about the science that directly impacts how we do the assessments each year. So just so you know, there's a lot else going on in the world of shrimp science. So I'm going to talk about the data that we use in the stock assessment, but before I dive into that, we need to talk a little bit about what stock assessments try to accomplish. And then I'm going to talk briefly about basic stock dynamics, just really to get some terminology out there. And then a little bit about how the models work, or how models work in general. And Anne's going to go into the specifics of shrimp modeling, but just to give you some background so that you understand why we collect the data that we collect in the way that we collect it. Then I'm going to talk mostly about survey data, and then a little bit about all the other data that we have that goes into a stock assessment. So a stock assessment tries to accomplish, well, at least three things. The first thing is just to try to give us an estimate of how many fish or shrimp are out there. You know, you can't look out at the ocean and know that. They're hidden from us. So, and it's not always easy to tell how many there are, but we really need to have an understanding of that and where we are compared to where we were a few years ago and where we might go from here. So you have to compare, you know, if you can estimate what's out there. You know, if I told you that there were 500 million shrimp in the Gulf of Maine, you might say, wow, that's a lot. Or is it? You know, the number itself doesn't really mean anything unless you have something to compare it with. Well, how many did we have 10 years ago? How many are we going to have next year? So you have to set some benchmarks, and Mike talked a little bit about that, and Anne's going to talk about that some more. And then the third piece is, okay, if you know where you are and where you are relative to where you used to be, what should you do next? How do you create a sustainable fishery? So the concept of sustainability is something I think everybody understands, but I have a little graphic to describe it the way I picture it. So if you start with a few shrimp at the beginning of a time period, say a year, there are a number of things that are going to happen to those shrimp in the coming year. One thing is that you hope that they will grow during the year, so I've made these shrimp a little bit bigger. And then another thing that can cause the stock to increase is that new shrimp will be born and added to the stock during the year, and we call that recruitment. So I've added some little bitty shrimp to my picture here, and we still get the two big ones in medium. And then there are some things that are going to happen to the shrimp throughout the year that cause the stock to decrease. And one of those, and a big one for shrimp, is natural mortality, just death from natural causes. And for shrimp, that's mostly predation. You know, they're eaten, like Jessica said, by just about everything. And we think that natural mortality probably happens mostly on them when they're really small. And then again, when the 5-year-old females have hatched off their eggs, they go through a molt, and they don't seem to survive that very well. They don't usually show up in any great numbers after that. So I've removed some of the little ones and one of the big ones from my picture here to illustrate natural mortality. And then, of course, there's going to be fishing mortality. And so the fishermen are going to get, you know, what's left. And we hope that they'll probably concentrate on the larger animals. So I've removed this big one. And you hope that when the year's all done, that you're where you were when you started in terms of your stock abundance. You hope that the stock hasn't gone down during the year. So if you can keep doing this cycle year after year, taking an appropriate amount out while the stock replaces itself, you will have a sustainable fishery. I know this is pretty simple-minded, but for some people, this, you know, it's a kind of a helpful way to visualize it, I think. So these things on the left make the stock increase in size, and things on the right make the stock decrease in size, and they're all things that we need to model if we're going to try to predict what's going to happen So, and Ann's going to talk about, each of those components a little bit more. Okay. So the next thing in understanding why we collect the data that we do is to understand a bit more about how models work. And the best way I have for thinking about that is thinking about a really simple-minded example. And bear with me if you've heard me do this spiel before, but I find it useful to think about a stock and that you have some index of abundance. And you'll hear us talk a lot about relative indices. And a relative index goes up when the stock goes up, and it goes down when the stock goes down. But the actual number doesn't really matter, or the units, or whether you're talking about whether you're measuring it in landings or in catch per unit effort or survey index. It should be some number that you feel represents the stock, that you have some confidence in. And so let's say you have this number, this index of abundance. You've gone out and done a survey, or you've interviewed fishermen, or you've done something that gives you a number you have some confidence in. And let's say that that number is an 8. Your stock is now at the level of 8. It doesn't really matter whether it's, 8,000 pounds a day, or it's 8 lobsters per trap haul, or it's an index of 8 kilograms per tow on a survey. It's an 8. And to keep this example simple, let's pretend that our stock is not going to be influenced by growth, recruitment, or natural mortality. We're just going to ignore those for the moment. And so the only thing that can change your stock is the landings, is the removals by the fishery. So your stock has got to go down. So you conduct your fishery, and let's say you take out 10 million pounds. And then you conduct your survey or whatever you did to get your index again. And let's say this time your new survey index is a 4. So you went from an 8 to a 4 when you removed 10 million pounds from the stock. So by removing 10 million pounds, you cut your stock size in half, right? You went from 8 to 4 by removing 10 million pounds. So that tells you that you must have started with 20 million pounds. 20 million pounds gave you an 8. You removed 10, half of it, that gave you a 4. So now that tells you you must have 10 million pounds left, right? Had 20, removed 10, now you've got 10 left. So that gives you biomass estimates. Basically, it gives you a starting biomass estimate of 20 million pounds. And then at the end of the year, let's say this was conducted over a year, you now have a biomass estimate of 10 million pounds. So this is what we call scaling an index to landings. And this is what a lot of models, not all of them, but quite a few models basically do. The CSA that we use, the surplus production models, the BPA they use in herring, are all based on this idea, this concept. Note that this is not an estimate of total abundance or total biomass. It's what we call exploitable biomass. It's the fish or shrimp that are going to make themselves available to the fishery because it's scaled to landings, right? It doesn't include animals that are too small or too remote, that are too hidden, that there's one here and there's one over here, but they aren't close enough to be commercially exploitable. So there are a lot of reasons why fish are not exploitable by a fishery. They just don't make themselves available, or they're too small, or they're poor quality, or for whatever reason. And so this method doesn't measure those. It just measures what we call exploitable fish, the ones that you can expect are going to make themselves available to you. And so if you go through this exercise every year and you keep track of it, your landings and your index, you can build this history of biomass estimates. Now let's take our example 1 year further. Let's do it again. So we had 10 million pounds left. We had a 4. Let's say we go out and conduct the fishery again and we take 5 million pounds. Okay, so what would you expect your index would be? Anybody? 2. No. You would expect that it would be a 2, but we went out and collected our index and it was a 3. I'm just making this up, but this is what happens in fisheries. You are never going to get the number that you expect you're going to get. Just when you think you understand something, Mother Nature will do something else, and you won't get a 2, you'll get a 3. And luckily, the models know how to deal with that. We call that just natural variation. Hopefully your index has what we call an error structure around it, a plus or minus, so that you know how certain you are about your index. And so the model will say, well, okay, maybe if you didn't take exactly 5 million, maybe you only took 4.5, and if that first index wasn't really an 8, maybe it was really only a 7.5. And it doesn't do that. It doesn't change your input data, but it will sort of try to find a middle ground that's what we call the best fit. And so it will still give you biomass estimates, and it will just adjust things slightly to find its way through the data to give you the best biomass estimate fit that fits your observations, even though your observations aren't totally consistent with each other. So you've probably heard the phrase best fit a lot. It's a statistical technique, but that's what it's trying to accomplish, to fit an estimate when the data don't exactly point you directly at a number. If the data are kind of pointing you kind of like this, the model will pick a number in the middle. Okay, so I think I've beat that to death. Okay, so you need a good index. I think that was the point of what I was trying to say about that. So there are a number of possibilities to use for an index of stock abundance. Landings data have been used when you didn't have anything else, but we all know that there are a lot of things that can influence landings, particularly the market. You might just not have a strong market one year, so landings aren't high. That doesn't mean there weren't any fish, it just means there wasn't any market. Conversely, if a lot of people decide to fish because the market's really strong and your landings are really high, it doesn't necessarily mean that you had a lot of fish. It means you had a lot of fishing effort. So landings are not necessarily a good indicator of the health of your stock. So if we have something better, we try to use that instead. Catch per unit effort from the fishery is something that you've probably all heard about. For shrimp, it might be pounds of shrimp per hour towing. Lobsters, it's pounds per trap haul. That can be a better indicator. You would think if your stock were more abundant that people would be able to catch more of it in say an hour of fishing, and if it were less abundant, that you would catch less. But there are ways in which fishermen can adjust so that they often will keep their catch per unit effort pretty steady, even if the stock is declining. And especially if it's an animal that schools, which shrimp do, an animal that aggregates together. As long as you can find an aggregation, even if it's the last one, you can still have a pretty high catch rate. And there's a classic example, and I'll go into that in a minute. So when I first started working for DMR in fisheries, the first species that I worked on was sea urchins. And I think we got really burned by relying heavily on catch per unit effort indices when we were monitoring that fishery. It was all we had. We didn't have a survey. We had pretty good landings data and catch per unit effort data from interviews with fishermen, and we plotted them faithfully. And I know this is kind of a mess, but the main sea urchin fishery is divided into 2 management zones, from Kittery to Rockland, and then from Rockland to the Canadian border. Zone 2 is the eastern zone, and Zone 1 is western. And so we started collecting these data in 1994. And it's pretty well accepted, I think, that Zone 1, which is represented by the red line catch per unit effort, that fishery collapsed. By the early 2000s, it was collapsed. The stock abundance was, less than a tenth of what it was when it started. And there's very little sea urchin fishing in southern Maine now. But if you looked at the catch per unit effort data for Zone 1, you don't see that. You don't see it at all. You did for about the first 4 years. And in Zone 2, you saw a decline in catch per unit effort. And the way catch per unit effort works, if you see a decline, that's probably not good. But if you see an increase or a stable catch per unit effort, it's not necessarily good news. It's kind of a one-way indicator. If it's going down, that's bad. But if it's not going down, it's not necessarily very informative. What was actually happening here, what I think is right about here, a big slug of Zone 1 fishermen just gave up. They just left. There's huge attrition. And we did a test on this, and it turns out, this is kind of a no-brainer, that the people who left the fishery were the ones who were doing poorly. So the people who stayed in were the ones who were most successful. So you would expect if you had a pulse of people who were doing poorly leaving your fishery and the best ones staying in, that your catch per unit effort should immediately go up for no other reason, because you've gotten rid of what we call the dubs. And you've kept the highliners. And if you're only now interviewing highliners, you should see your catch per unit effort go up for no other reason. But what also was happening here, I think, was that people finally just abandoned Casco Bay and moved east where the fishing is better, which is something we call serial depletion, when fishermen just move from place to place or deleting the stock as they go. And unfortunately, that was happening in Zone 1, but when you go out and interview fishermen, if you don't take into account what's happening spatially, you don't catch that. So right around here was when people started fishing in Booth Bay and Tennis Harbor and points east. And so we saw kind of an increase and then a decline. And then it just kind of bounced around, not very useful. And I think this right here, this increase we've seen lately, which now the Zone 1 guys, and there are about 25 of them left, and they have a 10 or 15-day season. And now it looks like they're doing much better than the Zone 2 guys, and it's pretty well accepted that Zone 2 has more sea urchins than Zone 1. So what's that all about? Just looking at catch per unit effort, you now think that Zone 1 had more sea urchins than Zone 2, and that just isn't true. They have a much shorter season. They only have a 10 or 15-day season, so they're getting the sort of the best of if they fished a longer season, you would see that their catches would decline throughout the season, but because they have such a short season, their catches are quite high at the beginning, and there's only a few of them. And they've also kind of changed their strategy from here. They're now fishing for volume, when back in here they were fishing more for quality. Sea urchins, you get paid more if you get a higher quality product. So that's kind of gone away. So now there's all kinds of things happening here. There's how the fishermen fish. There's who's fishing. There's serial depletion. There's all kinds of things that can affect a catch per unit effort index, and that's why we don't use them unless that's all we have. So, and this isn't just me talking, just my bad experience that I had with my first fishery. It's there are other people who've said the same thing. Good catch rates can create the illusion of a healthy stock. CPUE indices usually stay high during fishery collapses, making us think that stocks have not fallen as rapidly as they really have. These folks are influenced by what is the classic example of this, which I think is the Newfoundland cod fishery, where catch per unit effort indices stayed high right up to a total collapse. So, scientists have learned from this, and we try not to make this mistake again. So that's why we rely most heavily on surveys. I'm going to talk about the shrimp survey. And go back to this slide of Jessica's. This was developed by fishermen, by the way. This was, their perception of where the shrimp are. And I don't know if you can read that as the summer distribution, and then where they are during the winter. At least the female shrimp, which move in during the winter. I don't know whether they included any down east fishermen in this project, because there's traditionally been a fishery around Mount Desert and Mount Desert Rock. But generally, this is our perception of how shrimp move and where they're located. So how would you survey this? Well, first, the shrimp survey was developed back in the early 1980s. And the scientists then had quite a bit of information to work from fishermen and from other surveys. This is the spring nymphs trawl survey. And the blue dots are where they caught shrimp. And the black dots are where they caught no shrimp. So that helps you right away sort of focus in on where you should be surveying. Obviously, not very many, no shrimp south of Cape Cod, none on George's Bank, very few in the eastern Gulf of Maine. We know that Canada has from time to time had a little Bay of Fundy fishery. It's pretty small, seems to come and go, and we know that there's off of eastern Nova Scotia, there's a shrimp fishery. But it looks like the Gulf of Maine stock is very isolated. It doesn't look like it's being influenced by what's outside of the Gulf of Maine. So we consider this a single stock, and that's important. We'll talk a little bit more about that. But there doesn't seem to be a break along the coast, so that you'd have one stock here and one stock here. It seems to be pretty continuous. So that's the spring. Oh, go back. I'm sorry. The spring survey, you can notice that the shrimp are kind of bunched up along the coast, and that's because they've gone inshore for the winter, and they're still sort of on their way back offshore. If you look at the fall survey, it's a little better mixed, but there's still definitely the big concentration of shrimp in the Gulf of Maine seems to be in this area here, and that's where the scientists back in the early 80s decided to focus the survey.
Maggie, what's the red on that?
Oh, I'm sorry. That was for another project. I think that's Three Dory Ridge and Jeffreys Bank. We were talking about this, and it got written in on this slide. Also, if you're going to do a survey, you don't want to be surveying where there's no fishing going on. I mean, if there's no fishing, happening off the coast of Nova Scotia, we don't need to. We wouldn't survey there anyway because it's not our jurisdiction. But you want to see where's the fishery happening, and this is from 2011. But there was similar. It was pretty similar back in the early 80s. That there's a lot of fishing happening, in the Western Gulf, inshore, and there's some down east. But predominantly it's right along here. So that also influenced the decisions of where to conduct the survey. So why didn't we just use those NIMS spring and fall survey data? Well, the spring data were very erratic because the shrimp are still moving. And so they were not considered. The fall data are better, but this is from the 2008 fall NIMS survey, and it's great, it's surveying in the right area, but it's really sparse. I mean, there just aren't a lot of points on there. Really not enough that you would want to, base your whole management on the fishery. In this area, there's only about a dozen points, and it's just not enough. And it's also because they're doing it right now. They do it in October. We don't have the data from it in time to use it in the management of the next winter's shrimp fishery. So we do look at it. We do use it in our models, but it's not our primary survey. It's not the thing that we put the most weight on. So this is an example of what the scientists in the early 80s developed for a shrimp survey. And I should mention here that there's more than one kind of survey. This is a survey designed to come up with an index, a relative index that goes up and down as the stock goes up and down. There are other surveys that actually directly give you a measurement of how many fish you have. This is not that. Those kind of surveys would use something like an area swept calculation, where if you know how wide the mouth of your net is, and you know how much ground you've trawled that net along roughly, and you know, let's say, you know, a certain number of square meters were actually trawled, and you caught 100 fish, you know, in 1,000 square meters worth of trawling area. Then you just multiply that up over your total area to get a total estimate of how many fish are in that area. That's not what this survey is. In that kind of survey, it would be absolutely critical that you include all the area of interest, you know, to your stock. In this survey, this is 2009. It shows where we surveyed, and most of the points on here are picked at random. And I know fishermen have a really hard time with that concept, that we're picking sites at random. We're not going to sites that we know are going to have shrimp. And people often ask, well, why don't you go where there are shrimp? I can tell you where there are shrimp. You didn't go there. Why not? And it's really the same problem as I talked about in the CPUE estimates. And it's also a problem in that if you only go to certain sites year after year, what if something changes? What if the shrimp decide to move half a mile and you're fishing here for them in your survey and they're not here anymore, but they are over here? Now you have no idea of that. You're going to think that the stock collapsed if you rely just on going back to the same places every year. We do have some places in the survey that we visit every year, and those are indicated with the little white dots. And we've set up, or the scientists back in the 80s set up what we call statistical areas. And I don't know if you can see these outlines, but there's about a dozen of them. And they determined that there would be at least a certain number, a certain minimum number of tows that would be done in each of those areas, plus 2 fixed stations that were either recommended by fishermen or some were from the old main survey that we had. And so that's done every year, the 2 fixed stations in each of these 12 areas, and then a certain number of just random picks. And that means that every site has a chance of being picked. Over time, you're probably going to end up surveying everywhere, unless it's bad, you know, not towable. We did abandon Region 12 and Region 11 a few years ago for budget reasons. They never really seemed to have very many shrimp. Since they were the furthest offshore, they were the most expensive and took the most time to get to for not very much return. But this is the way the survey's been done every year. Where the dots are every year will change. But the protocol is exactly the same. The gear is exactly the same. It's a standard trawl with an 1 3/8" mesh so that we can catch some of the smaller shrimp that the industry might not see. It's only conducted in greater than 50 fathoms.
Yeah. Okay, that was part of my question. So are you randomly selecting among shrimp bottom, like among mud bottom canyons?
Yes,
Okay.
It's totally random. The limitation is towable. It's got to be, you know, when they get there, if it's not towable, they'll go to the nearest place they can find that is towable.
Yeah.
So it's not stratified on habitat, it's just stratified on these boxes. In other words, we're not saying, okay, here's this full set of shrimp habitat, you know, muddy, whatever, and selecting randomly from those, or selecting randomly within these
Within
boxes.
that whole box. So you could be on a high spot, a towable high spot or something.
It could be.
Okay.
Yes.
You just said that you guys, when you pick the spot to tow, you don't always go by what the fishermen tell you, so that if the stock moves, but there's no tows in eastern Maine. How do you know the whole biomass hasn't moved east?
Okay, that's a great question, and we've been losing some sleep over that one, frankly. We know that there is some shrimp, at least in the winter, it's getting caught down there. If you look back, people talked about, the shrimp are in Jordan Basin. Well, at least historically, which is right about here, there hasn't been a big concentration of shrimp in there. What we think is that the bulk of the stock is here and that it moves like this, in the winter. which would explain why the down east shrimp come a little later. They have further to go. I don't know. It's just, this is all theory. But remember how indices work. If there are shrimp out here that we're not seeing, that's not necessarily a bad thing if they go up and down the way these shrimp in here do. Okay? So, because it's a relative index. If there's a stock of shrimp out here that is a separate stock, it moves independently. It goes up when this might be going down, or it goes down when this might be going up, then we have a problem. And we have been, luckily we do have these other surveys to look at. We have the main inshore trawl survey in the spring and fall we've been looking at. We haven't seen a big shift of shrimp from west to east, but that certainly would explain some of the things I think the fishery's been seeing.
But you've only looked at the trawl for the last year, first time you tried that?
We did some extra tows for shrimp down east after the main spring trawl survey last year, 2011. They went to the edge of Jordan Basin, didn't find anything, came back inshore. This was in May, so it's hard to say where shrimp are in the spring because they're moving. And they came back inshore and did a few more tows and found shrimp very similarly to what they had found during the regular inshore trawl survey. So they didn't see any evidence of a big offshore population. But I think the jury's still a little out on this one. Not totally comfortable. I've looked at the inshore trawl survey results for the past few years, and there's no shift, from west to east in that survey.
It's certainly nothing back in the 60s or 70s. Because it was a similar situation that happened back then.
Hi, Maggie.
Yeah.
I'll touch the base a little bit on that. The biggest mass of shrimp that I've ever seen or heard of in my lifetime has been around Machias Bay, Beals Island, Jonesport. That started in 65. No, I'm sorry, 62, and it stayed going heavily until 65. But that was the biggest mass of shrimp that I ever heard of in all my life. But Bowling always has a lot of shrimp, but and they've been shrimp down there all my life. Come and go, okay, up and down.
Where do you think they're coming from?
I can't answer that, but I'll tell you one more thing that I am worried about the science part of it this year. The water temperature this year, what it's going to do to the shrimp, and they might, I don't know, might kill them all. But everything changed this year. The lobsters have changed, the fish have changed. I'm getting tropical fish in my traps now that I've never seen. Okay, so we got to be awful careful on what we do.
Right. So I guess the best advice to us is to keep checking not just the summer survey, but all the other surveys and all the other sources of information that we have to make sure that this is still valid.
Is there any plan to extend the shrimp survey further east this year?
If we could come up with some money, I would love to do that, to add another week down east. So talk to Pat.
Go ahead.
Would it be a possibility to leapfrog some of those? I mean, I see you've got a concentration in those two kind of central statistic areas.
Mm-hmm.
Could you leapfrog maybe that concentration a little bit further east? Maybe 2 or 3, 5 points.
You mean to remove some of
Yeah,
our effort
lower
here?
the concentration there and move it there.
Yes. I don't know.
No, okay.
I mean,
I think we'd have to have some more evidence that there was
Okay.
something out there. But anyway, I just want you to all know that we are thinking about this and worrying about this and worrying about whether the survey is still appropriate for this stock and watching the inshore trawl survey indices really carefully.
and the fall survey, and it's fall survey, which surveys the entire Gulf of Maine, so you can, it may not have the density of stations as this, but it does survey the entire Gulf, so you can see, in the fall anyway, is there evidence of a shift? And we haven't seen that in the fall survey.
How far north does the fall survey go?
You can go back.
Picture is
That's the spring, that's the fall.
the dark spots are where they sampled and did not catch shrimp. So it shows you between the blue and the dark, it shows you the distribution of sampling.
This is 1983 to 2010 data, just all lumped together.
What platform are they using? I thought Bigelow, are they using the Bigelow?
Yeah.
I thought the Bigelow doesn't go north of the 42-degree line anymore.
As far as I know, there's still.
So there could be a lot of survey points there that from the previous survey platform.
I'm not sure about that. I didn't think that they had changed the range of the survey. I'm not even sure exactly where 42 is.
Those
points
cover many years.
But even so,
Yeah.
this is.
It's all the points
That's
over
all
all
the
of
points over all the years.
Yeah, this is.
So it looks like great coverage, but in any one year, it's a little sketchy.
Right.
So I guess my point was, in the last number of years since the Bigelow has come online, I don't think that they're surveying the northern Gulf of Maine.
We better. I don't think that's true, but I better check on that, I guess. But this actually includes only 1 year of the Bigelow, this time series. But it's also not updated through 2011. I mean, the Bigelow started in the spring of 2009. Now, so this would be 2 years.
We looked into this question after the workshop was over, and it turns out the Bigelow has continued to sample above 42 degrees north. This is from the spring survey, and this is from the fall survey in 2009 of where they sampled and took tows.
So just a little bit about what happens on board. They do, I think it's 15-minute tows. They don't use a grate. They're using smaller mesh than the industry is allowed to, so they're catching everything. We do use some of the fish data in other stock assessments, but the shrimp are sorted out from the catch and they're weighed and measured. There are also, several different species of shrimp that can be caught. We're interested in Pandalus borealis, so that's identified. So I think that's enough. Those survey data are summarized by calculating a standardized, stratified, log-transformed mean number of P. borealis per tow. And I can talk about what those words mean if you wish, but in the end we come up with a single number for the whole tow, for the whole survey, and we plot it over time to give us an indicator of what the stock is doing. We don't just look at one number either. We look at how many shrimp less than 22 millimeters, how many over 22 millimeters. We look at numbers of shrimp, we look at weight of shrimp. So there are a bunch of different indices that come out of the survey, as well as the size structure of the population and how many males versus how many females, which is very interesting. Jessica told you about their hermaphrodism. And it's important for us to know, even though we're really only interested for the assessment in the larger animals. And I don't know if everybody is comfortable with reading these kind of graphs. It's what we call a size frequency distribution. It's telling you how many shrimp there are of various sizes based on the width of their carapace, the length of it, I mean. And you can think of these as piles of shrimp where the smallest shrimp are on the left-hand side, and the biggest shrimp are on the right. And they're also, the shrimp are sexed on board the boat, so we know which ones are males and which ones are females. And the female shrimp, luckily, have a spine that they lose when they carry eggs. So we can identify shrimp that have carried eggs and ones that haven't yet. So the ones that haven't carried eggs yet, but we expect that they will in the coming winter, is this reddish color. The females that have already carried eggs and we hope are coming back to reproduce for a second year are this orangey color. We can see in general they're bigger. And then there's a group here of males that we think are the 2.5-year-old males. And there are some males that seem to stay male quite long, quite big. So sometimes you get some really big males. And then you also get a look at what we think is the shrimp that are about 1.5 years old. They're, the 1-inch ones. So they're not very big, but it's our first look at a new year class. We think of these as year classes. You can see age 1.5, 2.5, and then 3.5 and 4.5, because their growth slows down, so these last two groups get kind of muddled together. So this is just a typical survey. I averaged all the surveys together, and this is sort of a typical structure, size structure for the stock during the summer. And then, for instance, the 2011 survey, we got this kind of a size structure, which was troubling for a couple of reasons. This new age class should have been right about here, and it just wasn't there. We just didn't see any new ones having been born in 2010. They just didn't show up. They didn't really show up in the inshore surveys either. And then these, what we think is the 2.5-year-old males are here in pretty good abundance, but they're small. They don't line up right under here where you'd expect. They're back here a bit. They haven't grown this fast. Same thing for the females. There's a pretty good abundance of females last year, but they were small for their age. And you can also see they're mostly 4-year-olds, not 5-year-olds. And you expect there to be more of what are going to be 4-year-olds, purple color, than the orangey ones, because the older ones have undergone an extra year of natural mortality and fishing mortality. So that's the fact that there's more red than there is orange is what you would expect. That's not unusual. But it just surprised us that these were, they should have lined up under here and they're back here, which indicates that they're a couple millimeters small for their age. So anyway, that's the kind of data that we get from the summer survey. And also we collect it for the fishery as well. Okay, so I think I beat the summer survey to death. There's a lot more information, but I wanted to talk most about the summer survey because I think that's the most. Go back to the summer survey. One more thing I wanted to say. Go back to the map. The red dots in the summer survey are where we caught the most shrimp, and I've talked about why you don't just go there every year. You don't just go to your hot spots each year, because what if they move? But I just wanted to repeat the importance of thinking of this as a relative index. If there were a site out there that went up and down as the total stock goes up and down, you could, let's say it was here. Let's say that that's always been a good spot, but it's not such a good spot if the stock is low and it's a really good spot if the stock is high. You could conduct your whole survey just by taking one toe.
Is that Portland Harbor?
I don't know where that is. I just want to make the point of the difference between a relative index and an index where you actually go out and try to count all the shrimp in the area. If you could find one site that went up and down representatively, then that would be all you would need to do to do a survey with one toe. So that's kind of crazy, but not realistic, but I'm just trying to make a point. Yes, ma'am.
What about hollow dots?
The hollow dots are the fixed sites, the
Okay.
sites that we do go back to every year. And they're just sort of a kind of a check. Like if you had a survey and an index came out really bad, really low, you would ask yourself, well, did we just happen to pick bad sites that year? I mean, the random pick can, conceivably there's a chance that you could just pick really bad sites. So we have those fixed data to look at and see, well, how did they do? How did the fixed sites do? And usually they have tracked very closely with each other. Yeah.
And one of the things is, so I know that you guys do your kind of track the population. Do you guys track anything else in terms of where you're actually catching it? In terms of the ocean? So if you're seeing a lot more fish, has there been any trends that you can see in terms of where more shrimp are being caught over a period of time?
Well, we haven't seen. This is always hot. This inside Jeffries, that's always one of our best strata. And again, off Casco Bay. But I don't think I'm answering your question.
And I guess you guys kind of track what the population's doing, right? But I was just wondering if you guys look at it spatially as well at all to see if there's any type of, all right, so we stopped doing the trawls in the southern area, but the trawls that we have been doing down south, they've been getting smaller and smaller and smaller over the past 5 years, or
Yeah,
is there
we
anything
don't-
like that happens?
I wish we had the time to do that. Yeah, we haven't done much spatial stuff. I'm very limited in my GIS skills, so that's not great.
Oh, we plot the distributions every year.
Yeah, we do this every year. We plot it, we look at it, we compare it with, we have a time series, so it's a little slideshow where you can see every year. We haven't seen any real big shifts or trends yet.
But geographic changes in size distribution.
In the size distribution.
Yeah, I feel like we're kind of doing that last year, some stuff for the stock assessment.
Mhm.
Are you doing that again for this year's stock assessment?
We'll definitely look at it. You mean like how we showed that the Downies
Yeah.
shrimp tended to be bigger? Yeah, we're definitely interested in that. We've never had enough data
Right.
from Downies to really do that. But last year we sampled the heck out of those poor guys. And yeah, I'll just very briefly talk about there are lots of other sources of data that we use in the assessment, and I'll talk a little bit about. They're equally important. I dwelt on the summer survey because I think there's been a lot of confusion about that survey. And it's like, you didn't survey this one little area, so you missed the shrimp. Well, that's not how that survey works. It's not that kind of a survey. But we do rely heavily on the landings data from the dealer reports and the harvester reports. We've been using the harvester report data for the assessment since 2001 because it is a little bit more complete than the dealer reports, which are only from wholesalers and processors. The dealer reports don't yet include the peddler sales, but the harvester reports do. There's been kind of a chronic problem with the timeliness of those reports coming to us. For instance, we're about to do our assessment for this year. We still don't have all of the last of 2012's harvester reports yet. So again, we're going to be using incomplete data, and you can see from that example I gave that having good landings data, everything is scaled to the landings, so you really need to have that complete. We also do a dockside sampling program where, and probably those of you who are fishermen have been interviewed on the docks by Leslie White or Marilyn Lash in Maine, or maybe by Jessica and Brant in Massachusetts. So we have that program, and that's really, it's very important. It gives us effort and cash per unit effort, and I know I kind of downplayed how important that is, but we do look at it, we do report it to the managers so they know what's happening with cash per unit effort. And we also look at the size and the sex of the shrimp that are caught. We calculate count per pound, things like that, and we report that to the managers. That also comes very importantly into play in the model, because we need to know not just the weight of the shrimp that are caught that we get from landings, but we actually try to estimate how many individual shrimp in numbers are caught. So we do that by counting how many shrimp there are in a pound from the samples that we collect from the fishermen. So that's really important. And then we use selectivity data from gear studies to try to figure out, we know that the industry doesn't catch very many of those little shrimp. We know that they're going to focus on the larger ones, and that plays into the model. Again's going to talk a little bit about that. And then we do look very often at these other survey data, and we do use the NIPS, these other surveys in one of the models. So I think I'm getting told that it's time for me to stop. Yes. Dennis?
The anomaly that we have, I call it an anomaly, 2007. On the graph.
Yep.
What has happened in the ensuing years to either prove or disprove that high figure? Is there anything, and how did that affect your model as you use that data?
It does affect the model. The model is going to think that there were a lot of shrimp that year. The model will also recognize that it's not consistent with the year before and the year after, and it will do that best fit thing where it will, it'll take that peak and it'll kind of smooth it out. We looked at the fall survey. The fall NIPS fall survey was also very high that year, The Maine, New Hampshire inshore trawl surveys were higher, but not like that, not crazy like that. That survey year had the fewest number of tows that we've ever done. They had a lot of technical problems on the survey that year. They only got in 29 tows that were used in the assessment. Usually we use, over 40, so that may have had an impact on that. So yeah, the model will try to fit that, but it is a problem.
Other questions? On the catch size sex data, I'm thinking there's and maybe I'm wrong. Is there any consistency in the point of time of the season, but December, January, February, that way versus how that shows up?
Yeah. Okay, so this is from the summer survey. I have it with me, but we don't have a slide of what the catch size looks like. But usually, they don't get this. They don't get much of that, and they get a lot of this and a few males. They get more of the small males in December until like a couple of years ago when the shrimp, they seem to separate out pretty well in December and come in early. The last couple of years, I think. But traditionally, December you would get more of the small stuff, and then again in April and May you get more of the small stuff as the females work their way offshore. Sort of joining the areas where the males are, and the fishery goes out to chase them. Did I answer your question?
Yeah, I think so.
Any other questions on the data?
Two questions. One on this one. The assumption that the lower graph is actually shifting left. Why couldn't the assumption also be that the graph is shifting right? Instead of slow growth, you have passive growth.
Good question. The year before, 2010, which I'm not showing, there was a pretty good slug of shrimp here where you would expect. 2011, you would expect them to have grown and a new year class arrive. Now, it's possible that new year class was really big and you've got 2 year classes piled on top of each other here. I don't think so.
Or you missed a year class, which we've done before. Right? You missed it in 2011 that you saw in 2010. And we've seen that before.
So that the big one that we saw, well, it wasn't big, it was moderate year 2010, just wasn't caught in 2011.
Well, no, I'm just asking about the assumption. What you mentioned was the assumption that it was shifting left.
Again, and I don't have it here, but in 2010 there was a pretty good slug of these males here, that should have grown to where these are here, but it only shows up here. I wish I had the 2010 graph to show you. They do kind of flow, but they just don't flow quite as far as they usually have.
The second question I have goes back to your slide that had, I believe, how you entered the summer survey data. And a question on the log transform. I believe that originally on the CSA, we weren't transforming them then because of inconsistency. We started to log transforming them.
We started log transforming in about 1997 when Steve Kagren said this is a better way to do it.
Right. So could you give an explanation of the effect of what really the effect of log transform data is?
Log transforming is a statistical technique. I may want to have Ann explain this because I'm not very good on it. But when you have really patchy data, you have variance around your survey indices, which I haven't really talked about. But you don't want your variance to go up if your abundance goes up. Variance is something that you try to keep constant. But in a patchy situation, you often find that your variance goes up at as your abundance goes up. So, and that's not considered a good thing for the statisticians and for the modelers who are assuming that that doesn't happen. So a log transformation will reduce the variance to a more constant level. It will, it'll bring the extremes down in your data. And it's a standard technique. The fact that we log transform was peer reviewed thoroughly in 1997. And they said, yes, you should be log transforming your data. And we've been doing it ever since. But I really would need a statistician to explain it better than that. I know that wasn't very good.
Yeah, I mean,
You want to talk about it?
Yeah, I was just going to say that's a good explanation. That the effect of doing the log transforms is basically it smooths out the data a little bit. Is what you're going to see in terms of the indices. And the effect of the log transformation has a bigger effect when catches are more variable. So, that's what you're going to see.
Right, it essentially brings down the highs.
It smooths things out, yeah.
And it brings up
was,
the lows.
It brings
and
up
it was
the
done. It was done because of the inconsistencies in the model running the straight data at the time.
Well, it was done because the model's structure actually assumes that this, Meg is talking about the mean variance relationship, it assumes that it's of a particular type we call additive rather than multiplicative. And so by doing that transformation, you actually can meet the requirements of the model. So it's a statistical structural thing that should be done according to the structure of the model.
Right.
And that's why
But,
it's done.
but the original CSA did not.
I don't think that's probably true. I don't know.
I think the CSA was adopted at around the same time that the log transform was started.
Yeah.
As I remember, we were running it consistent with our surplus protection before it was brought on as the model, and in running it parallel, the inconsistencies were found. This is my recollection, and then it was determined that we had to transform the numbers. So for a number of years, when we were running it parallel, only to observe it. It wasn't part of the assessment. There were problems with the inconsistency and the spikes in the survey data, and to level that out and to make the model be able to fit the model, the numbers had to be transformed. That's how I remember.
That could be true. And that's, like I said, that went through a pretty thorough peer review and has been re-reviewed twice since. Apparently, it is the appropriate way to handle that data.
Just keep on schedule here. We'll get one more question. Do you have a question?
Yeah, I wanted to ask Meg again, where on the graph showing the size and stuff, where we caught a lot more bigger shrimp to the east, is it possible that the mass of bigger shrimp moved further east for some reason and it's not shown there because there was no survey?
Again, it comes down to where are those shrimp coming from. We don't know. We don't think there's a big abundance in the summer down east.
But with the last couple of years with the water temperatures changing, it is possible,
It's possible.
that the mass is moving east.
It is possible. It's not showing in, the Maine and Shore Trawl Survey. So it's kind of a mystery. Yep. But it's definitely something we're
Fishing up
concerned
there
about.
has been a lot better the last couple of years. And I haven't been every year, but for quite a while, it's been a lot better than it has for quite a few years.
It has. I agree. Fishermen will also tell us that as the shrimp seem to come in waves, and they seem to get a little bigger as the season goes on. And since you're getting yours late, maybe you're seeing the waves of slightly bigger shrimp. I don't know.
2 years ago, we had them in January.
Yeah.
Okay.
It was right there. When the inshore opened up, the shrimp were there. And the same, pretty much, not as much last year, but still early.
Yep, yours are definitely bigger. We have documented that. A little bigger.
All right. Thank you, Maggie.